Hey everybody, this is Larry. This is week 5 of the Leetcode daily challenge, or weekly challenge. Haven't done this one before. Yay! Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. 256 paint house. There's a row of N houses where each house can be painted one of 3 colors, red, blue, or green. The cost of each filling house is certainly different. A certain color is different. You have to paint all houses such that no adjacent houses have the same color. Alright. So N is 100. This is going to be a standard dynamic programming thing, right? Basically, I mean, maybe there's a smarter way, but I think dynamic programming solution is going to be pretty straightforward. The idea, of course, is that the best you can do at each house, as long as you choose a different color, that's fine, right? So let's just say calculate, and that's just a lazy name, index for the suffix of the cost, and then the last color, right? So something like that. And then basically the idea here is, yeah, if index is equal to n, then we're done. So then we can return 0. Otherwise, yeah. I mean, I'm going to write it out. You could write it with a for loop, and maybe you even should. But yeah, if last is not equal to 0, then this is, I think, red. They don't actually, they just kind of said red. I know that it doesn't matter what the I know that it only has 3 things, and it doesn't matter which one is red, which one is green, and which one is blue or whatever. But it's still a little bit sloppy to kind of not have it explicitly. Like, you know, the 0 index is red, 1 index is blue, 2 index is green or something like that, right? I mean, I know that, like I said, it doesn't actually matter for the problem, but it's still a little bit lazy, to be honest, if you ask me. Just like on the problem setting. But in any case, so yeah, so if it's not, because I would have liked to change these into enums, but in any case, yeah, so if it's not 0, then we can calculate index plus 1, 0, right? Plus the cost of index 0, something like that, right? Basically, if it's saying that the last house is not of the color 0, then we use 0. Otherwise, we also try for 1, right? And like I said, this is actually pretty straightforward to have a for loop, but I just wanted to visualize this a little bit for y'all. I don't know if this is easier to visualize, but yeah. Like unrolling the loop manually. And that's pretty much it, really. Right? And then we can do something maybe like we calculate, and then like 3 or something like that. It doesn't really matter as long as it's not, you know, the first one can be any color, right? And there you go. Of course, this branches 3 times every time, so you're gonna run into some sadness in the complexity. So what we should do is memorization, and then that's pretty much what we're gonna do. As cash as you can. Index can go from 0 to n. Last can go from 0 to 2 and maybe 3 if you want to, depending on how lazy you're on here. So yeah, so here we're gonna write it out as cash as you go to right? And that's pretty much it, really. I mean, you know, I've written DP a lot lately, so I feel like I'm being a little bit lazy today. But yeah, the core concept is that you just kind of, you know, the important concept is that this last is not matching whatever you put in the next color. And of course, like I said, you should probably replace this with for loop, but I just wanted to kind of, well, if I had like enums, this would probably look more sensible because I have like red, green, blue or something, right? Then I would have just said like if the last one is not red, then we make it red, right? And something like that, but it didn't really work out that way because I guess I could have just done it, but these don't even necessarily match the colors that they give you, because you know it's a little bit awkward because you know because they don't actually label them, I don't think, unless I misread it. But yeah, I mean, it's one of the 3 colors. They don't tell you which one is, you know. I don't know. Anyway, that's all I have for today. That's all I have for this one. Let me know what you think. This is going to be linear time, linear space. And yeah, you can actually make this actually constant space if you like. But, you know, I'm not going to go over here. I have a video for space optimization. Definitely check that out. And that's all I have. Stay good, stay healthy to mental health. I'll see y'all later and take care. Bye-bye. Have a great rest of the week, everybody. Bye.